Hi, I want to make my own high voltage capacitor. But what is a capacitor? It is basically made by any two electric conductors placed close to each other with some electrical isolator between them, like two wires running parallel to each other or two lovers separated by glass. I love you too. A capacitor stores energy in form of electric fields. If there is a path to place some charges on one side, then it attracts the opposing charges through the other path and charges the other side. Now, even if I cut the paths, it will hold on to its energy. And the first popular capacitor that was made like 300 years ago was called a Leyden jar. It has quite a simple structure. And I also noticed that the King of Random Jr. made one, and I watched the video, and let's just say I don't appreciate misuse of capacitors. Well, that's quite rich coming from me, I guess. And thanks to circuit specialists, I'll give away two Hantex scopes at the end. I mean 200 MHz 2-channel scope for
very low price.
What is your excuse for not scoping curves? Let's make a Leyden jar and explain it. I took a plastic bottle for vitamin pills and peeled the label off because the thinner the wall, the higher the capacity. I covered the outside of the bottle with aluminum foil as one side of the capacitor plate. Cut the extras, tape the edges with electric tape. There. Then we put a metal screw or nail at the center of the lead, all the way in so it can get into the water in the bottle later. I can't put metal plate on the inside of the bottle, so instead I fill it with water, which is not conductive, and then add salt to it to make it conductive. So now the aluminum on the outside and the conductive salt water on the inside are the two isolated conductive plates of my capacitor. And now I add some length of metal wire to the end of the screw, which will help increase the surface contact to the salt water and reduce the resistance. Now this is pretty much done, but the actual Leyden jars have a smooth metal sphere at the end of the rod that removes all the sharp edges where the charges can run away from. I don't have a metal sphere, but I have a ping pong ball that I can wrap inside aluminum foil and make it as smooth as possible. Put the end of it around the screw and cover the rough surfaces with electric tape. And we're done. Let's see if I can measure the capacitance. According to the meter, the Leyden jar is around 1.5 nanofarads, which is pretty small, but it's around what it should be. Now King Jr. used a PVC pipe and rubbed it with paper towel. PVC picks up negative charge, and he charged the bottle like this, which is incorrect, helping me with the material I need for my video. Thanks, King. What is wrong? A capacitor is a two-terminal component. If charges come in from one side, the opposing charges need to get in from the other side. The way King Jr. is doing it, it is still getting charged, but not as the capacitor it is, but as anything can pick up charge like this PVC pipe. The outer surface likes to become positive because the negative charges on the inside of the bottle repel the electrons on the outer surface. But they have nowhere to go until he touches the surface.
Try grabbing the foil and then touching the nail to see if I get a shock. Oh, I got a shock just from the foil. That's not how it's normally supposed to go, but...
So now the jar has a chance to give out some of its electrons to King Jr.'s body and become positive, while King Jr. becomes more negatively charged. Now when he touches the center of the Leyden jar, the discharge is not too great because both the center and his body are charged negatively, and the remaining energy dissipates through his body.
That was a little bit of a shock.
Let me show you how to do it properly. The outer surface is connected to earth, which is also connected through this wire to my body and grounds my body. I hold the towel in one hand like this and rub the PVC pipe against it while passing it over the center of the Leyden jar, like this. Now when I do this, the PVC pipe picks up negative charges and places them at the center of the Leyden jar, which repels the electrons on the outer surface into earth. The towel becomes positive, so it sucks electrons from earth through my body and becomes neutral again. So next time when I pass the PVC through it, it can send more charges through. It's basically like I'm pumping charges into the capacitor. I have to hold my hand a little bit further. This is very much the same way a Van de Graaff machine works. Do you hear the charges going in? Okay, let's see if it picked up any charge. I forgot to unground myself. That was painful. No more touching it with hand. I made another grounded ball to discharge it. Let's try it at different number of strokes. I made it darker too so you can see the arc. Okay, 10 strokes. Yeah, a little bit. That looked like a 1 kilovolt discharge. Here's 20 strokes. Not bad. It was probably around 5 kilovolts. And here's 50 strokes. Wow, that was strong. Maybe around 10 kilovolts. Okay, 100 strokes. Whoa, that was like 15, 16 kilovolts. And then the King Jr. tried to charge his Leyden jar using one of those plasma globes, which is very much the same as a Tesla coil, and that wouldn't work either.
See if it did anything. Nothing. Nothing whatsoever.
The reason is simple. Something like a Tesla coil outputs high frequency AC arcs, while a capacitor shorts AC, so there wouldn't be any charge buildup on the capacitor. Now I want to see how much current it can send through my body, so I'm gonna use a 1 ohm shunt resistor in series with my body, so every volt is 1 amp, and 20 strokes or around 5 kilovolts, and measure across the shunt using my scope. Okay, 20 strokes. Of course, this is not going to be super accurate due to the line inductances and the fast nature of the discharge, but we'll see. Okay, ready? Ow! Ow! It hurts where it goes in and where it goes out to the ground. Of course, this is much worse because its capacitance is around 5 times larger than a regular discharge a human body experiences. So the duration of the pulse is much longer, and a 5 kilovolt on this one can hurt as much as 25 kilovolt of a regular discharge. I like King Jr. or Senior try this one. And if you look at the plot, you see there is a fast spike of up to 12 amps through my body, and then the current stays around 5 amps and discharges slowly to 0 in around 7 microseconds. Here's the screenshot if you want to see more accurately. So although the voltage and current are super high, I'm saved by the fact that the pulse duration is very short, so the energy is limited. If the voltage is high, the current is high. Now this capacitor works, but it's a piece of junk. Why? Because every capacitor has an equivalent series resistance or ESR that we try to minimize. But this guy has a huge one. The huge ESR contributor of this Leyden jar is the awful conductivity of salt water. If I open... Forgot to discharge the damn thing. Let's open it. Now if I measure the resistance between the salt water and the top ball, it's around 3 to 4 kilo ohms. It's huge compared to regular capacitors with milliohm ESR. Now I want to make a high voltage, high capacity, low ESR capacitor, and for that I bought this, which is a desk cover made of material. I suppose it's some sort of mylar or something. I cut 2 sheets out of it, and hopefully there are no punctures on it, otherwise the high voltage will always find a way and arc through and ruin the voltage rating. I also cut 2 sheets of aluminum foil half an inch shorter than the mylar on each side, and I'll glue it on the mylar. I put some glue on and spread it in a very thin layer. Then I stick my aluminum foil on right at the center. And make sure it's completely flat and thin. Very nice. Then I just tape a piece of flattened wire like this to one corner of this sheet. Then I flip it around and glue the next sheet of aluminum right behind the first one. Now I tape another wire to the opposite corner of the first wire on the second sheet. Okay, we have our basic capacitor. Let's measure its capacity. Yeah, it's around 5 nanofarad. We are already ahead. But now we'll roll this tight. This way the layers will overlap multiple times, increasing the capacitance much more. But now that I think about it, rolling it should only bring the outer surface of one beside the outer surface of the other one. So double the surface area and double the capacitance? Am I wrong? Let's check it. Crap, I totally forgot. First I had to put the second layer of mylar, otherwise I would short the 2 layers. And now we roll again. Okay, let's see what we've got. There you go, much smaller than the Leyden jar, and its capacity is around 10 nanofarad, much more than the Leyden jar, and I think it can still do upwards of 10 to 20 kilovolts. This will take forever to charge using my PVC pipe though, being almost 10 times my Leyden jar. If this took 20 strokes to get a decent arc, this will take around 200. Well, I can charge it to 2000 volts using my microwave transformer through a puny single diode rectifier. Let's give it a try. Okay, is it charged? Let's see. Ooh, it is charged. Well, not big enough though. I really wish I had a Bondograph machine so I could charge it to 1,000,000 volt or more. Maybe I should make one of those. Giveaway time! The good people at Circuit Specialist have provided 2 Hantek scopes to give away to my patrons and viewers. I have used this scope briefly before and have seen good feedbacks about it too. So if you're also into scoping curves, you can become my patron at patreon.com or sign up from the link in the description for free. It is on sale for
very low price.
Do you know how much you can learn by seeing actual waveforms? Do you?